has found x5. We know the root lies between 1 and 1.125. So we find the next guess by finding the midway point between. That comes out at 1.1. Everybody can. Oh. Now that rounds to 1.13 to 3 significant figures. That's the number of significant figures we're looking for. The only reason for doing that is to check for that number, that round be the same twice. We then stop our iterations and we've got our result. Okay? But when we put the new guess to the function, we've got to put the full one in, not the round. Yeah? So that goes in there. I get a result of 1.7013, which is still positive. Therefore, my root lies between 1 and 1.125. I use that to calculate another new guess. I get 1.0625. Rounded to 3 significant figures, it's 1.06. And when I put that full value into there, I get an answer that's still positive. My root must be between 1 and 1.0625. So I use 1 and 1.0625 to find my 7th guess. 1.0315 rounds to 1.03. And I put that full value in the function, it goes negative. So that guess now lies between 1.0315 and 1.0. We've crossed the x-axis because we've gone from positive to negative. It's possible that we might be going the other way if we're looking for that negative root over the other side of the function, but it's a change of sign that signifies you need to replace one of the limits. So x8, looking between I get a new x8 guess of 1.046875. That rounds to 1. This one in the S 054687 rounds to 1. And I can say to 3 significant root 1.05. If you get a change of sign, and those figures understand where they come from now. Yeah? Right. What I want to do now is extend the technique to a little bit further. To use the bisection method to determine the root of the equation x plus 3 is equal to e to the x, correct to 3 decimal places. In this case, finding the root will determine the value of x where the two sides of the they on the graph. So where the function x plus 3 the function e to the power of the x. Graphed both functions, and we'll look at the value of y i.e. on the right hand side. So I've done that there. Subtract from both sides, and now I've equated that to it. Therefore, between two. Off you go. See if you can use bisection method step by step to find out to, what would we say, how many significant, 3 decimal places this time. Places. So you for that to be the same twice, 3 decimal places. You're trying to find the value where these 2 lines cross. If you look, yeah, when these 2 lines cross, so that's so you're not looking for where x is 0, you're looking for the root. If I graph x plus 3 minus e to the x, that'll shift, that'll draw the x-axis at that root.
So we're basically start 5, and then 2, 4. Then you put that formula together.
Yep.
Then you got 0.
Yes. You're looking. You can. In the function and see whether you've got to change the sign. You're looking puzzled, Jake. Right. New page. I'll get you started. Right. And become a root. That's the point of doing that bit, is effectively that creates a function that crosses the x-axis at the same point. Because what you're doing is taking the value of this is e to the x, you're taking the value of that and taking it off, so you're moving at that. Yeah, no? So that's the only reason for doing that bit. A function we're going to use, we know that x1 is a value of 1, x2 is 2. We know we're 1 and 2. Yeah, we're all happy with that, right? And our function is x plus 3 minus e to the x. Okay? So our next x3 is equal to 1.5 to 3 decimal places. That's that. Be complete in our method. Okay? And our 1.5 is 1.5 plus 3 minus e to the 1. Yep. Just Eight, 3, yeah, positive, yeah. Our answer lies between 1.5 read or not? Function value negative and 1.5. So our fourth guess is that. Sorry? One. That was our first go. Yeah? The function at 1.5 is 2. So we must be 5 and 2. Because that's negative at 2. Let's put that up there. Function at 2. When we get yeah. Yeah. 1 point. and the function at 1.75 is what. So that's going to replace the 2, isn't it? Yep. Guess is 1.750 to 3D. One, 2 and 1.9. Now you're going to 1 point. But you're that I use this spreadsheet. you get a full answer to the positive. As it's magic, as there is. Right, Jake. What you're looking at is where does this yeah? So it's still positive. Two on the shape of the function. Right? So we get a new guess of 1.75. That takes us from positive to negative. So 1.75 has got to replace the old negative. In this case, but it depends on. So our new guess is now going to be five. While most recent positive, the negative one stays the same. See how this one changed, then that changed several times. Yeah? Because all these ones were new negative values, new negative guesses. And then we're gone positive again, and then negative again, and then we've got to this point twice in 2 iterations running. Stop. Because that's what we started here, and that's not every problem, Jack, right? And the value of the function is negative. So we know what lies. That's our positive. We then find a new root. -1, and we replace the old positive guess in, and we get a negative one with this. Look, because that result positive, the 1.5 went in there. All these results are negative, so we're replacing the negative value negative, so that value goes in there. Go positive again. This value has gone in that one. You get it? Then we go neg again. That value's gone in there. Lastly, we go on. That value's gone in there. And we get. So once. Yes, those guesses do say the most recent positive, most recent negative. This one in terms of first guesses then. We got 2 ln x plus x equals 2. So we can say 2 ln x plus x minus 2 fx is equal to 2 ln x plus x minus 2. Do about first guesses. Oh. So let's go with 1. Is what? Is that a lucky? So, Tom? So we you know how do you know? So but you I have to sign them. How? But it isn't, is it? But it isn't. What does the what we're going to do, don't this thing. It must be. Yep. Comes out positive, you then got to go lower. Small. No, that's fine. That's fine. So, what we can say now, then, therefore, we'll start 0.25 and x2. Now, you can just go through the same process. If we change the value of x between 0.5 and 1. So therefore our root lies between 0.25 and 1. So our next guess will be halfway between the two. Right,